All right, we are going to be talking about section 7.1 today, which is radical expressions. Most of you have probably already dealt with radical expressions in some way. It's basically just taking the square root of anything. So if I say the square root of 25, I'm asking what times what? X times x equals 25. And so, of course, that's 5. So the square root of 25 would be 5. So we have a way in which we say the principal root, and that means the root that we're usually talking about. And all that means is that when we're taking the square root of something, we're usually going to take the positive root. Because as you can imagine, 5 times 5 equals 25. But also, negative 5 times negative 5 equals 25. So technically, 25 has 2 square roots, but we're going to be looking at the positive one. So in numbers, you can just write the positive one, but when you're using variables, and the variables are by themselves, then you're going to want to put absolute value around them to distinguish that we're talking about the positive one. So there's essentially just a few things that you need to know about this. One, square root of 64, 8. These are really simple ones because these are perfect squares, and so these are ones that you're kind of used to. Square root of 9 is 3, square root of 4 is 2, square root of 1 is, of course, 1. But some of them you're going to have to do a little bit of work. So one of the things that I want to show you is what's called the house method. And so if I want to say, take the square root of a to the 10th, okay? The way the house method works is it supposes, bear with me, that this is a house. And the rules of the house, there's an understood 2 here when there's nothing written. Sometimes we'll have a 3, which is a cube root, or a 4, which is a 4th root. We'll get to that in a second. But assume there's nothing there. We're going to assume there's a 2 there, okay? So the rules of the house are 2. That means that to get out of the house, I need to have at least 2 of whatever I want, okay? So watch this. If I say the square root of a squared, how many a's do I have? I have a and a. So I have 2 of them. The rules of my house say that I need 2. So this pair comes out as 1. So that's why that equals a. Okay, let's do that with a number. So what times what equals 9? This is called factoring. You might have also heard it called a factoring tree. So that goes into 3 and 3, right? So how many do I need to get out? I need 2 because that's the rules of my house. Well, I have 2 right here, so that means that a 3 comes out. So the square root of 9 is 3. Let's try that with something that's not as easy. So how many a's do I have here? Well, I can actually break that up into 10 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't suggest you do this every single time, especially when the numbers are this large, but this is a good way to show. So I need groups of 2. That's the only way that I can get out. So that means these guys come out, these guys come out, these, and these. So I have 5 groups of 2. So that means 5 a's come out. And notice that 1a represents 2 that come out. Okay? 1a, just like 1, 3, represents 2 that come out. And so this is the house method that we'll talk about a little bit more. Now, let's do something where the house rules are a little different. So, the cube root of 125. Now, dealing with the difference in sum of cubes, you probably already know off the top of your head what the cube root of 125 is, but let's assume that you don't. If you look at 125, we need to factor it. What do you think 125 can factor into? Well, it looks like it's divisible by 5, and because I know that if I divide $1.25 by 5, I have 5 quarters, then I know that's 25, right? And that would factor into 5 and 5. How many do I need to get out? I need 3 of them to get out. Well, I have a group of 3 right here, so that means that one of these comes out. So the cube root of 125 equals 5. Okay? And let's try that just one more time. I'm going to do the cube root, or the fourth root, sorry, of 81x to the fourth. Now let's look at the numbers first and then the variables. So looking here, I know that breaks down into 9 and 9, and I can further break those down into 3 and 3, right? How many do I need to get out? I need 4 to get out. Well, I have a group of 4 here, so that means that a 3 is going to come out. And then, how many 4s do I have? Or how many x's do I have? Sorry. 1, 2, 3, 4. How many do I need to get out? I need 4 to get out. So, that goes right there. Now, this asks a natural question, which is, well, what if they don't all come out? We're going to get to that a little bit later, but I'll give you a sneak peek right now. If I were to say the cube root of x to the fourth, 1, 2, 3, 4, how many come out? Well, only one group of 3 of them do. So that x would come out, but then the other x would have to stay inside the house. Simple as that. Same with numbers. If I said the cube root of 16, 4 and 4, 2 and 2, 2 and 2, well, a group of 3 2s can come out, but this 2 has to stay inside. Okay? This leaves one more thing to talk about, and that is domain. I know you guys love domain. So, the square root of x minus 2. Well, we can take the square root of any positive number. That's pretty easy. We can even take the square root of 0, because 0 times 0 equals 0. But what we can't do is take the square root of a negative number, because if you think about it, a positive times a positive equals a positive, and a negative times a negative equals a positive. And so there's nothing we can multiply together that's the same that would give us a negative, right? And so there's no square root of a negative. Technically, there is a square root of a negative, but that's imaginary, and we're not going to talk about that yet. We're going to save that for later, so get excited about that in the future. But for our purposes right now, there is no square root of a negative. So I cannot do anything that would be the square root of anything less than 0. So what I'm going to do is say x minus 2 must be greater than or equal to 0. Simple enough. Just like when we were solving after factoring, we would find the zeros of different equations. It's essentially the same thing, but I'm saying x minus 2 has to be greater than or equal to 0. And then I just solve. So x must be greater than or equal to 2. So that's it. That's my domain. Pretty simple, okay? And there's some nomenclature that we'll use for this, but we'll talk about that a little bit later on in class. Any questions about this? No. This is a video. You can't have any questions. Sorry. So, let's move on to 7.2. Now we're going to talk about rational numbers as exponents. I'm actually going to make this a separate video so you don't have to watch it every time.